everyone, welcome to our channel Code Emblem. Today we are diving into the fascinating world of data visualization with Seaborn. It's this awesome Python library that lets you create stunning plots to make sense of your data, to make a good insights, and whether you are a seasoned data scientist or a data analyst or just a beginner into the Python programming, uh, this video is for you. Now, let me tell a bit about the Seaborn. It's built on top of the Matplotlib, another popular data visualization library, but it takes things up a notch by providing a high-level interface for creating beautiful and informative statistical graphics. What's really cool about the Seaborn is its simplicity and elegance, making it super easy to create complex visualizations with just a few lines of code. Seaborn offers a variety of plots that suit different data visualization needs. Let's just take a look of the code walkthrough. I'm just importing the libraries, that is Seaborn. If you have not installed Seaborn in your Jupyter notebook, then you can use this code, that is pip install Seaborn. Here you can see that I have already installed it in my Jupyter notebook. Again I'm importing the numpy as an np, matplotlib, and warning messages to ignore the warnings. Then I'm loading the data set, that is the pre-built. I mean, there are many pre-built data sets in Jupyter Notebook that you can load using the load underscore data set. Here I'm using the tips data set and I'm storing it in tips. Next, I am viewing the first 5 records of this data set. Here you can see the first 5 records, and this dataset consists of 7 columns, and here we are seeing the first 5 records. Now, uh, now let us visualize the count plot. Count plot simply counts the occurrences of each unique value in a categorical variable and displays it as a bar plot. It is useful for understanding the distribution of categorical data. Here we are using the categorical column, that is 6 column here we are using, and we are displaying mm, the number of the number of male and female uh, records that are available in this data set. Here we can see the more number of males are there in this data set, and less number of female. uh, then we are viewing the shape of this data set, and the shape of this data set is 244 and 7. Here 244 means the rows and 7 are the columns. 244 records and 7 columns. Then we are also viewing the dist plot. Distribution, this is nothing a distribution plot. This plot combines the histogram with kernel density. Distribution plot combines the histogram. This is nothing but a histogram, and this is nothing but a kernel density. To provide a comprehensive view of distribution of single variable. Here we are using only single variable, that is a tip column, and we are plotting the insights of this distribution plot. It perfect it This distribution plot is perfect for understanding the spread and the shape of your data. Here we are taking number of bins as a five bins, that is we are taking number of bins as a 5, and here we can check there are only 5 bins, 1 2 3 4 5, and you can see there are more number of from the range between from 1 to 1 to 4 there are 1 to 4 there are more number of tips. And then moving forward, we are plotting the KDE plot. KDE plot is nothing but it's a plot that is used to visualize the distribution of a single variable only with the KDE, and it provides a smoother representation of data compared to a histogram. Here we can see we are using a shade equal to true to provide this, to display this color, and it is giving a smoother representation of the data compared to this histogram. Next, moving forward, we are using the joint plot. Joint plot is nothing but it allows you to visualize the joint distribution of two variables along with their individual distributions. It is perfectly used for understanding the relationship between two variables and identifying any underlying patterns or trends. Okay, you can customize this using a kind parameter. In the below code I have used kind parameter. I'll explain it later. And you can also use here hue parameter to add a categorical variable for color differentiation. Okay. Next, we are using this joint plot. Here in this you can see I am using the total bill and tips column. Here we can see the histogram plot and scatter plot. It is displaying the two plots. That is why it is called a joint plot. And this is displaying only the relation, correlation between the two variables, that is total bill and the tip. Next, we are also using for this joint plot. Here we are using kind equal to regression. Here regression is nothing but a best fit line. As we know that we can use kind parameter to using the kind parameter we can use the KDE plot and scatter plot and also the regression plot, KDE scatter and regression. So we are using regression REG for the best fit line. Now you can see there is a density in this. We can see the density in this histogram plot in the joint plot. Also, there is a line that is appearing in this. There is a line that is appearing in this plot. This is nothing but a trend line or a best fit line. It displays the correlation between this is displaying the correlation between the total bill and as well as a tip. Next, we are using, as I have said, we can use a regression or KD or scatter for the kind parameter. Here I am using KD. So here you can see the joint plot combining joint plot is combining. It is displaying the relation between the total bill and the tips variable using the KDE plot. And I am using shade equal to true to display this. Here we can see that the most of the values are lying between 0 to 0 to 30. 0 to 30 you can see more number of values are lying, and this is a positively skewed one, skewed KDE plot. You can see the dataset names by using this get underscore dataset underscore name. Because I want to use another data set in this data visualization, so I'm listing some of the data. I'm listing the data set that are available. You can use this code get underscore dataset underscore names. Here we can see there are many such data sets like Titanic tips that we have used in this previous one. Now we are using iris data set. Let's download it. I'm downloading it using load underscore dataset iris, and I'm storing it in iris, and I'm displaying the top 5 records of this iris. Next, I'm viewing the value counts of these species, like how many species are there in this data set. Here we can see there are 3 types of species, that is Setosa, which is having 50, and versicolor, which is also having 50, and virginica, it is also having 50 counts. Next, I'm displaying the scatter plot. In this, I'm using the iris dataset. So I'll be using the sepal length and petal length uh, variables, and here I'm using the species as a to display the relation between the species and the petal length and sepal length. Okay, so here we can see blue colored dots are called setosa. Versicolor is nothing but orange color, and virginica is in green color. Here you can see that there are values that are sepal length values are lying between somewhere around 4.5 to 6, and sepal length of versicolor is appearing from around 5 to 7, and sepal length values of virginica is appearing from 5.5 to 8. Likewise, we can see the petal length values are appearing of setosa are lying between 1 to 2, uh, and petal length values of versicolor are appearing from 3 to 5, and petal length of virginica is appearing from 5 to 7. So this is about the scatter plot. Scatter plots are nothing but they are used to display, used to display the relation between the data points. So we can see that the pair plot. We are using the pair plot. Pair plot is nothing but it creates a grid of pairwise relation between the variables in a data sets. It's a convenient way to explore correlation and patterns between multiple variables at once. So that we can see the relation between the species and other columns like sepal length, sepal width, petal length, and petal width. The correlation between these columns at once in the figure. Here we can see the sepal length is appearing like a KD plot for the same column. In the diagonal way, as a diagonal way, you can see that these plots are appearing if if it is for a same column name, it will appear like a KD plot, and for other column names other than it itself, then it will appear as a scatter plot. Here we can see the sepal length and sepal width of this plot, and sepal length and petal length plot, and sepal length and petal width. Likewise, we can see sepal width and sepal length here, and sepal width and petal length, and sepal width and petal width. Likewise, you can see all the um, plots are paired. Next, we are going to use a bar plot. Bar plot is nothing but it displays the mean or another estimation of central tendency for a numerical variable grouped by one or more categorical variables. It's useful for comparing categories of data. In this, we can see we are using the smoker. We can see that a smoker is nothing but it is categorical variable, and 6 is a categorical variable, whereas tip is a numerical variable. So we are displaying the uh, mean or a central tendency for a numerical variable grouped with the categorical variables. These two are categorical variables. So we can see, here it is displaying if the smoker, if he is a smoker, then it will display as. If he is not a smoker, then it will display in orange. So yes will display in blue and no will display in orange. Three who are male and they are smokers, and who are not smokers, you can see it in orange color here. And likewise you can see the female, likewise you can see the female smokers and who are not the female smokers. And I am displaying the first 5 records of the iris dataset. And here I am using another plot called swarm plot. Swarm plot is uh, swarm plot is another type of plot that displays categorical data with points that do not overlap. You can see here, making it useful for visualization the distribution of categorical variables. Like you can see here, the setosa is displayed which is not overlapping with versicolor or virginica, and the same way versicolor species are not overlapping with setosa and virginica. Likewise virginica is also not overlapping with setosa and versicolor. Swarm plot is mostly useful to display the categorical data, and the points do not overlap. Okay. Next, we also used title to name this plot as a swarm plot. So